that electric dipoles. So can you please go for that a question? Whether I don't know you have did it or not. Can you please go for that question under that part, electric dipole moment? And unfortunately, I just missed that question. So can you please read that question? Who found that? Can you please read it? Biosense 53.
Yes, madam.
Can you read the question?
Which part, madam?
When we studied that electric dipole moment, I just left a question as a homework. Can you go for that?
Okay, madam.
You don't have? Okay, any others? Um, Physical science 73.
Yes, ma'am.
Did you find that question?
And the question in the last of the energy of a dipole, that
Yeah.
part, a point charge q at a distance
Give me some time to write that. Yeah, can you please?
a point charge q
Can you?
a point charge
Dear,
q at
are you hearing me?
yes ma'am
Okay.
at a distance r
Okay.
from a dipole moment p.
Mm-hmm.
The displacement vector of the charge q
Okay.
may an angle
Make.
mm,
Mm-hmm.
may an angle theta with respect to the
Mm-hmm.
I miss the last sentence.
Okay, so now can any others find this question? Anyone else?
Mm,
Now at least can you find this question? because I also just misplaced my notes somewhere, so I couldn't find it immediately. That's why I asked you, because this is an important question, and it will be helpful for your examination also. So that's why I thought to discuss about these questions, but no one is ready for that.
Madam,
So yeah, yes, dear.
under that, there are two questions.
Okay, okay. Let us
First one,
start.
find the potential on Q.
Okay.
Second one, find the electric force on Q.
Yeah, okay, fine. Okay. Anyhow, did you write this question? No. Okay, no problem. So what is mentioned here is we have already studied about this in our theory part, that under the dipole moment of that electric charge. Okay, so the important thing is when we have the dipole moment, we need to have plus minus charges. So then only the dipole moment will be there. So dipole mean there should be two polar charges. That mean one should be negative and other should be positive. If it is a minus charge, then if we have a plus charge here, then there will be a dipole moment, but is mentioned by P. That P dipole moment, the quantity of the dipole moment is equal to the charge, the value of this charge, time, the displacement between that we mention as here, okay, the point charge Q at a distance R from a dipole moment P, the displacement vector of the Q make an angle theta with respect to, it's not completed this question, right? So anyhow, this is the format of the question what we have studied in our theory part. So in our theory, we have well already did it. It's for example, if we made this as a D, the separation D or 2A. So if it is a D, then we can make it as D. Okay, so the quantity of the dipole moment will be equal to Q time D. Then it's mentioned that the P is a vector. So we know that it's having that quantity as well as the direction. So that is the another important things. Sorry, if it is plus, if the minus charge, the important thing is when we have that dipole moment, there should be a direction like this. That will be start from this plus 2 toward the minus negative charge. So like this, there will be the direction for the dipole moment. Okay, so in this type, if the P is going in this way and is telling that at R distance somewhere here, is from the center of this one, center point, this is, sorry, this point is mentioned at a distance r. So if we take this point as a or B, say this is point B. In this point, we need to find the dipole moment, the electric dipole moment. Okay, we know P is equal QD, and also that we can make this as like a triangle. So if the separations between D is not given, but you can take where it can be A and this also can be A. That means the separation can be 2A. So it's up to you. You can use any notations between that because P only is given, but you should have the idea that P can be connected with the charge because charge is given here, charge and there's also the separation. So here the D, in my case, I'm going to use D, okay? So D is as, okay, it's better to use A, right? So I'm going to mention as A. So according to that, this should be, P should be Q time 2A because separation 2A. So 2QA. This can be the magnetic, sorry, dipole moment, electric dipole moment, and the direction will be in this direction. So now what is telling that the P is making the angle theta for the displacement vector. That means displacement vector I'm just considering in this direction. So from this center of this dipole to the point B. So this angle given as theta. So clearly, first you need to draw the diagram. Then you can go for the other questions that could be easy for you. Okay, some of you completed the questions with respect to the direction of dipole moment. Dipole moment vector, that is as mentioned P. Okay, P always we need to have the underline because it's a vector quantity. Okay, now we know that using cost rule, so this is mentioned as r distance. Okay, so this is r distance. So the displacement is equal to r. So using cost rule, you can find what is this one. Okay, just say this is r minus distance, and this distance from this plus point to b make r plus. So using cost rule, you can find what is r minus, what is r plus in terms of a and r. Okay, so this will be able to find because this is already in your notes. I'm just giving or recalling that idea only to do such kind of questions. Okay, I'm not going to completely do this one. So in that is the way the question is telling, describing this kind of diagram, and then later you can find this one. And also after that, you can first question find the potential on Q. So now you need to find the potential is it cannot be like a potential on Q, potential at the point from this r distance. Okay, not on Q, due to Q. Okay, so this we need to find the potential at B, this point only. So we know that the potential can be due to the plus. So the potential will be due to the minus charge and also due to the plus charge. So we know that how can we write this potential? So if we just get the idea for the potential, and other one will be minus time the potential due to the negative charge. So then this potential having some these results. Okay, that mean it's having the notations r minus and r plus. Then when you substitute these things, check your theory only. Just follow the theory. Then you will be able to show that the potential is equal what is mentioned there in terms of P. Okay, P dot r cos theta over something. So this will be able to reach the answer. So whether if you need this point, you can stop it. If not, if they ask to do some other steps, you need to follow that and you need to do this. Okay. So this is the idea how to apply the theory for such kind of questions. Then after what they're asking in the B part, you need to find the force. Force we know that is equal Q into E. So if we know the potential, then we know that electric field will be minus time del of pi potential. So if we find this electric field, then you can just apply here and multiply by the charge, then you will be able to get the force. Okay, so just follow these ideas and try to do your questions. So now we will move to the next tutorial what is uploaded last time under this Poisson's equations and also under the magnetic field. So give me some time to raise them. Yeah, is there any doubt on this question to do this question? Any doubt? No. Okay, fine. So if we have any clarification, if you need any clarification, you can ask me. Okay, we'll move to the second one. Is it visible?
Yes, madam.
Okay, thank you. Okay, so here's the first question, which is related to Poisson's equations. And if we once we are ready to derive the Poisson's equation, then we can get the Laplace equations also when the proper condition is applied. Okay, so now here how to derive that Poisson's equation, and then we need to start this one with the differential form of the Gauss law. This is also it for the tutorial part. You have this one, right? I have given already in your theory. BS 148, Biosense 148.
Yes, ma'am.
Did I give this one? The proof?
Yes, ma'am.
Ah, okay, thank you. So I'm not again doing that, but you can derive that the Poisson equation is given. Uh, okay. Poisson equation is given by. Can you see this, what I'm writing? Is it visible?
Yes, ma'am.
Ah, okay, thank you. So this is the normal one, but we derive the Poisson equation. And here the first question is consider a solid sphere. Solid means it should be like a sphere, spherical shape one, solid one. So it's completely having some materials, right? So there's no empty inside. It's a solid one. So that should be fully having some materials. And the radius is given as R. Radius is given as R. Having a negative charge distribution on the charge of the charge density rho, because it's a solid material, so because of that it having the charges among the volume of this one. For example, if the total charge is q, then if we divide this charge by the volume of this sphere, volume of the sphere will be 4 3 5 r q, right? So if we divide by like this, then it will be mentioned as Q. But fortunately, in our case, Q only is given. Rho is given. Rho is the charge density. Okay. So now we can here also we need rho. If in some other cases, if they you should have the idea what we can the Q is given, you should give that in the terms of Q and R. Okay. So now, and then another important thing is there, but most of you, 99% of your colleagues didn't consider that. It's mentioned here, a negative charge distribution is there. Negative charge distribution means this Q charge can be or minus Q. That means if sometimes you're having the electrons on this sphere, then we need to apply minus q charge. Therefore, equal to plus rho over epsilon naught. Okay. So because of this minus charge, no, if they don't talk about this negative charge, then you can directly apply this minus sign. But they are mentioning that having that minus charge. So we need to have that Poisson. First, you need to write the Poisson equation, the original format like this. Then after, you need to show that the del square pi will be equal to rho into epsilon naught plus rho into epsilon naught. Okay. So now using the Poisson equation, find the potential at the point interior and the exterior of the sphere. That means inside and outside of the sphere. You need to find that inside and outside of the sphere. Okay. So now we know that it's a solid material, that solid sphere. So it having the charges inside the sphere also, and also along the surface, but not outside of the sphere, right? So be clear when you use the Gauss law and these Poisson's equations. What we are considering here, I have already given outside for the Gauss law. Just we are considering space, that the surface, and what is consist inside the surface. But here we are just considering region only. Okay. So now we know that del squared pi is equal rho over epsilon naught. Fortunately, here the rho is given as a rho. So in some time, if the rho is given here, for example, if the rho is given as rho naught, then where we need the rho, the dense charge density, we need to apply rho naught. Here, we should apply rho naught, right? But here, rho only is given, so we can directly use this one only. Okay. Now we need to find an interior and exterior. So if it is the small displacement, we need to give this region first. Inside the sphere, what is happening? So inside the sphere, charge is there. So charge density is given in this way. So we can directly apply that. But in the spherical polar coordinate, del square pi is equal to some expansion, right? So if we just apply that expansion, then only we can have that. What is that potential? What is the pi? So can you please tell me what is that del squared under the spherical polar coordinate? Anyone? Anyone? Physical science 73. Are you there?
1 over r squared
Give me some time. Okay.
dabba
Mm-hmm.
r squared dabba 5 over dabba r
Okay. Yeah, tell me.
Mm,
Any others?
one over sine theta
Plus.
plus 1 over sine theta
Okay. Plus. Okay, 1 over sine theta.
dabba over dabba theta
Mm-hmm. Is there a direction like this?
um, theta
Okay, tell me. 1 over sine theta. Dabba
sine
over dabba
theta
theta. Okay. Yeah, tell me.
dabba 5 over dabba theta
Okay. Other term?
plus 1 over sine r squared sine squared 5
1 over r.
dabba Sine is squared phi
squared theta, right?
theta.
Not pi. Yeah. Dabba squared
Dabba
over
phi over dabba squared
chi
dabba x squared. Phi is
chi squared. Okay. Okay.
squared.
Okay, here's the one. So now we can find that this is symmetry one. Sphere is the symmetrical one. It doesn't depend on this theta. Isn't that mean that's not varied on this theta and also the psi. So we can make this dabba pi over dabba theta and also dabba pi over dabba psi can be equal to 0. So these two term will be equal to 0. So now in this situation we can consider that L squared pi is equal to 1 over r squared dabba over dabba r squared dabba pi over dabba r. Okay, so this is the way. So now this is equal to plus rho over epsilon naught. So how can we have the dabba over dabba r squared dabba pi over dabba r will be equal to, will be multiplied by this r squared. So we can have that rho over epsilon naught time r squared. Okay, so if we integrate this, then the dabba over dabba r mean like a d over dr, right? So if we have the integration, this will be cancelled. Then what we can have inside the bracket, r squared dabba pi over dabba r is equal rho over epsilon naught is a constant, and again what we are doing, integrating with respect to r, right? So if we get that integration for that with respect to r, what we can have, r cube over 3. Okay. So now again we have r squared here, r cube here. If you multiply by, sorry, divide by r squared, then dabba pi over dabba r will be, because this integration is going from 0 to r direction. So integration is going from 0 to r. Therefore, we can have the same one. And in this situation, dabba pi over dabba r will be equal to rho over 3 epsilon naught time r squared, and r will be cancelled. So r will be there. And again, by having integration, then pi will be pi inside the sphere will be equal to rho over 3 epsilon naught time r squared over 2, right? So this will be the inside of the sphere. Of course, you can write it like a rho r squared over 6 epsilon naught. And now again, when this r greater than capital R, we are going to find that del squared pi. In this situation, rho over epsilon naught, rho is equal 0. There's no charge out of the sphere. So this will be equal to 0. Okay. So we know that the del squared is equal here in the spherical coordinate. R squared dabba over dabba r squared dabba pi over dabba r is equal 0. So if we integrate this and if we multiply by r squared, again we will have that this one is equal to 0. Okay. So if we integrate that, r squared dabba pi over dabba r will be equal to a constant. So we don't know what is the constant. So that will be equal to constant. Again, we need to define what is constant. Okay. So if we have the dabba pi over dabba r in this system, that will be equal to c over r squared. And if we have another integration, again if we integrate this, then in this situation, pi will be equal to minus c over. So can you do this one? Can you do this? Anyone, can you share your answer? Anyone got the answer?
Minus C over R.
Mm-hmm. Yeah. Complete answer. Is minus C over R integration? Okay. So now we can just compare these two when this R is equal, when R is equal capital R. So in this situation, pi will be equal to C over R, but we need to find what is C, right? So now we are going to apply this condition when this, sorry. Okay, if I erase this, the above part, is it okay? Can I erase this? How about others? Have you written? Biosense 135, BS 135.
Okay, ma'am.
Okay, thank you. Okay, I'm just writing here. When this R less than capital R, we found that the potential is equal rho R squared over 6 epsilon naught, right? When this R greater than capital R, in this situation, we found that. Can you see this, what I'm writing? Is it visible? Can you see these two lines? When this R less than R and small r greater than R. Okay, thank you. So here you can see that, but we found already pi in the situation when it's less than R is equal this one. When it is greater than R, this is equal to minus C over R. Now we will apply the condition, boundary condition, okay? When R is equal capital R, that is possible for the interior as well as for the outside, the exterior. So now we will see pi inside. Okay, this is pi in, this is pi out. So pi in will be equal to rho over 6 epsilon naught, and situation R will be equal to capital R squared, right? Likewise, V out also should satisfy that. So V out is the boundary condition when this R is equal capital R, that will be minus C over capital R. So now in the boundary condition, pi in and pi out is equal, right? So if we just equate these two, then C over R will be equal to rho over 6 epsilon naught r squared. So what will be C minus time rho over 6 epsilon naught r cube. So if we know that C is equal, then we need to substitute here. So in this situation, we can find that pi out is equal to minus time. Here also we have minus for C, so that will be plus as a, and rho r cube over 6 epsilon naught over 1 over r. So this will be the pi outside, the potential of the outside. So interior potential will be this one, and the exterior potential will be this one. Okay. So thereafter, what is that next part of that question? So, okay, here they ask only the potential. So we can just, we need to come until to find the pi. And again ask that the potential, draw the plot for the potential versus radial distance. So here, once they don't ask the potential, and if they ask that electric field, then we know that electric field is equal delta pi minus delta pi, delta pi. So here minus delta pi, if we have to apply this one, we can directly get it from that initial stage when it is minus time delta pi over delta r along this r direction. Okay, so if we just give this one, then in this situation you can directly apply this and you can find the electric field. Okay, now we know that what is inside the sphere, the potential, and outside the sphere, what is the potential. So now we need to draw the plot when this r is going, what is happening up to r. We know that when it is equal to r, then we have some value for that pi. So pi will be here, rho r squared over 6 epsilon naught in this time. When it is coming r squared, this value is increasing, right? Like this. And again, what is happening? When this r is increasing, the value is decreasing. So this will be, sorry, like this. It will be reduced. Okay, this is the plot you have to draw. And this for the first question. And the second, third questions are the theory parts, and you can just write down what you have in your notes. So we don't need to consider again here. Okay, second question. Briefly explain the type of magnetism. So it's already given for you. That is, and then you need to differentiate the ferry and the anti-ferro magnetism. Then what is mean by magnetic permeability? Okay. So the fifth question is the Biot-Savart law. That also is asked for the theory part only, but we have already proved them. So you can get the idea from your theory parts. Once that the values are given, you want to be able to substitute the values for these kind of questions. Okay. So in the fifth question, second part, they asked to prove that from the circular coil. Then after, hence deduce the magnetic flux density at the center of the point. Okay, here. Reduce the magnetic flux density at the center of the loop. So at the center of the loop mean where we consider D will be equal to 0. So if we just substitute D 0, then you will be get the magnetic flux or the magnetic field at the center of the coil. Okay. So now we'll see the sixth question. The sixth question is a wire of 1 meter long carries a current of 10 ampere. So here the current I is given as 10 ampere and the length of the wire is given as 1 meter and it makes an angle of 30. The long wire with the current angle makes a angle So if, for example, if it's a I, which make an angle for the uniform magnetic field B. For example, say this is B. It's a B is equal 1.5 Tesla. Calculate the magnitude and the direction of the force on the wire. So we know that according to the Lorentz force, force is equal I along the displacement, where we consider if the wire is like this, for this L distance cross B, the curl of or the cross product of the IL cross B, then we can find the value. So if we have two vector cross product, we can write it mod of L and mod of B sine theta along this unit vector. Along the direction will be given according to this the cross product of L and B. Okay, so now the F can be equal to I is given as 10 ampere and the L is given as 1 meter and the B is given as 1 point Tesla. All the units are in that standard unit, so we don't need to worry about it. 1.5 Tesla time sine theta. Theta is given as 30. Okay, so first we need to consider I curl of B in this direction. So using our right hand rule, we can find which will be the direction of the force. And here these two are not perpendicular, so we can find it where it will be along a small deviation. Okay, so find what is the value for, sorry, what is the direction of the force. So here is the magnitude for the force by just apply this one, sine 30. So now can you just calculate and tell me the answer? Okay, so some of you share your answers. Thank you for your response. So it should be equal to 7.5 Newton. This is also very important, the unit. Okay. So this is highly enough to have the ideas among your among your theory parts. And I should tell you that the final examinations will be covered because of 2 double credit course. There will be 4 questions. Okay. So the first question will be along the Gauss law. Okay. So the first question for the Gauss law, and the second question will carry that electric dipole moment with Poisson's equation. Okay. And the third questions will be that for the Biot-Savart law. Okay. The fourth one will be for the Maxwell equation and their applications. Okay, so it will be along the Maxwell equation. So just get the clear idea and try to study well, and you can ask your questions. Okay. Okay. So do you need any further clarifications? Do you need? Okay, you can try these tutorial questions also, what is given for the first tutorial. And here, if you have still any doubts among them, then you can just ask me. Okay. So in next lecture, that means tomorrow we will okay, and this will be along that. It will be cover actually. We have already did two, right? Okay, so this will cover the MBS law. Okay, so tomorrow is the exam that will be covered for under the MBS law. Is it clear? Physical Science 1.8. Physical Science 1.8. Physical Science 1.8. Are you hearing? Okay. PS C56. PS 56.
Yes, ma'am.
Okay, you got the points what I told, right?
Yes, ma'am.
Assessment, and I will arrange that submission through the VLE. And please, when you submit, at least when you submit the tutorial, sorry, the answers for your assessment, please use the VLE only and try to get that good internet connection, and please upload through the VLE only. Okay, don't try to share the WhatsApp or email. Even if you can't upload through the VLE, please don't share with WhatsApp. I'm never going to correct through the WhatsApp. Okay, so don't share your files through the WhatsApp. Just let me know whether you have not submitted. Then I will give you another and some other solution for that. Don't upload it. Okay, just put the message only for me, but try to upload maximum. Okay. Okay, fine. So we can stop here. Then we will meet by tomorrow. Thank you for your participation.